All right, hello everyone. Hi Funny, thanks for waving. Munib, thanks for waving. Andy, hi. Joshua, Harrison, Philbrook. Hey Summer. Oh man, I'm starting to recognize some faces without having the names pop up. There's Noah Green, Annika. Hi Marie, Matt Tibbetts. Hello Elisa. Good, there's Mabel Smith. Hello Valentina. Faye is thoroughly backlit. All I can see is a profile of the top half of her head, but that'll do. We all have our own lighting situations to deal with at home. You don't have to move, Faye, it's fine. All right, well, let's get rolling today. Chris McMullen, why don't you kick it off as you usually do?
Everybody, I hope everybody's having a good week and haven't forgotten about the midterm, which is next Wednesday. Just a reminder that I'll have another SI session tomorrow evening on Thursday from 5:30 to 6:45. And then also next week, I will have a midterm review session Tuesday at 5:30 to 7:30. That's a 2-hour session. I don't know how much time I'll have for questions. So if you have any pressing questions, tomorrow would be a better time to get that answered with I'll be able to give you a lot more attention then. And then there is no SI session next Thursday because of the exam.
Good, thank you, Chris. Gabby and Funny, any comments, updates, announcements?
Nope. Nope.
Okay. I have a couple of logistical things to cover. And the first relates to the midterm and its impact on the rest of the course scheduling. So we will have lab this week. I don't have this in the notes, so I'll update the PDF that's on the website, but we will continue with lab being recommended, but we will not take attendance this week in lab. Attendance has been, I could say, solid. You know, half to 2/3 of you seem to be coming to the lab sessions, which I think continues to let us know that there's value in them and that you're seeing that value, so that's good. There will be no labs next week. That is indicated on the syllabus, and that's of course because we have the midterm exam next week, and layering a new lab on top of the midterm doesn't seem appropriate. One implication of that is that the lab that will be assigned tomorrow and Friday, which is lab 6, basic programming, you will have 2 weeks to complete that lab, okay? I will suggest that you not just punt on it for a week and then come back to it after the midterm. It is a harder assignment than those that have come before. I think the kind of structured programming with functions and for loops and so on is more conceptually challenging, and this is a harder lab. So the 2 weeks is a bit of a gift, but also you, I think, need some of that time to be successful on the assignment. And it also, of course, means that you have access to our office hours over a full 2-week period. Although next week's SIs are related to the exam, there will be SIs, correct me, Chris, if I'm wrong, there will be SIs the following week that will be focused on the lab 6. So we hope that over the course of the 2 weeks, you'll have plenty of opportunity to get help in the lab 6 assignment, but it is not due next week. It is due 2 weeks from this week. Okay, I will take any questions or comments there are from the class, whether they be about labs or material from last time or the ongoing preparation for the midterm. All right. We're going to spend today and Monday of next week basically practicing. I'm not going to introduce much, if any, new material or new concepts, but it's been clear to me over the years that there is no amount of practice that is too much with regard to if, for, while statements and functions. So we're going to spend today and next Monday practicing a little bit more. And I'm going to start by writing a quick function to take a number and check whether it is even or odd, and then I'm going to vectorize it to show a for loop outputting the number of odds and evens. All right, so I will move through this relatively quickly, but you should please unmute yourself and speak up. If I'm doing something that seems strange to you or that you don't understand, please ask, and I will spend the time to describe it in more detail than I might be otherwise. And let me just make sure this file isn't already used. Okay, good. So I can edit a file, oddeven.m. And here's my editor window. And I'm going to write this as a function. So I went through a lot of, I spent a lot of time describing how I usually write a script and then write a function. I think in this case, I'm going to go direct to a function so that I can concentrate on describing functions again and showing you some of the coding methods that I'll use. So this is taking an input number and checking whether it is odd or even. So I have to start with my function keyword, square brackets. For outputs, I'll call the function odd even, and then it takes something as input, and I'll just call that num in, okay? My output is going to be a variable that I will name is odd. So you can guess maybe that that variable will hold numbers, zeros and ones, that will tell us whether the input number is odd or not. Okay, so I'll use a 1 to indicate that it is odd, 1 for true in MATLAB kind of logical speak, and a 0 for false or even. Okay, the first thing I have to do is determine whether in fact this input number is odd or not, right? And we talked about this a little bit, I think, several weeks ago. The definition of an even number is that it is evenly divisible by 2, right? So in this case, I think the easiest thing to do is to check whether a number is evenly divisible by 2 or not. I'm going to use some if statements here. So if the remainder of num in, comma 2. So that will take num in, it will divide it by 2, and it will return the remainder. If that is equal to 0, then the number is even. So if the number is even, I should let is odd be equal to 0. So is odd is false or 0. If that's not true, and let's see, I'll do this actually. So I'll do an else if the remainder of num in, comma 2 equals 1, then the number must be odd. And I should actually check what happens with the number 1. So I'm going to type the remainder of 1, comma 2 over there, and I do get 1. Okay, so I was a little bit concerned that MATLAB might not treat the remainder of 1 divided by 2 as equal to 1, but it does, right? So the answer to that problem is 0, remainder 1. If you remember back to, whenever you learned basics of division with remainders, 3rd grade, 4th grade, something like that. So good, so it works, right? So the number must be odd, and then I can say is odd equals 1. So the number odd, so is odd is true. Okay, now I've covered 2 cases, right? When the remainder is equal to 0 and when the remainder is equal to 1. But my user, which will be me in this case, might give a number like 2.7, right? Well, is 2.7 odd or even? It isn't either, right? Because the notion of oddness and evenness for numbers isn't defined for non-integers. So I'm going to try to cover that with an else statement, all right? And else is going to capture all of the possible other outcomes. And what I'll do is if, so else, the number is basically not an integer, I'll set is odd equal to NaN. And that's a special MATLAB value for not a number. And it's a useful value to know NaN because it's a useful way of sort of filling in a spot in a variable or in an array with something that indicates kind of something is wrong there, right? It isn't a number. It's not a number, and maybe the rest of the array is full of numbers, and something's gone wrong in that calculation. So having use of this NaN value in MATLAB is actually pretty useful, and it's often particularly useful in debugging or in error message returning. And I can even do something like a display of your number is neither odd nor even. Right? Okay. And then I need to end, right? So let me pause for a moment and ask people to look at that code and ask if there's something they'd like me to explain a little bit more.
When would you get a number that's not an integer?
Well, remember, the purpose of writing a function is for someone to use it, right? So say I gave this to my 4th grader, right? He's pretty good with odd and even numbers, but let's imagine he was only in like 1st grade. And I said, okay, I want you to be able to use this to figure out or to answer for you whether a given number is odd or even. Well, he may not know that non-integers aren't odd or even, so he might just be experimenting. He may type odd even of 2.7 or something like that, right? And I'm trying to cover that case. Another thing is that a user could make a mistake. They might hit the decimal point by accident in entering a number. They might mean to enter 27, but hit a decimal point between the 2 and 7. And so that's another sort of inadvertent error that I would be checking for here. Others?
So is there a reason you used a double equal sign?
There is. So this double equal sign and that double equal sign, right? And I didn't see who asked that question, so apologies for not using your name. These double equal signs are logical equals. They are what MATLAB uses to compare two values and return whether they are equal or not, a logical true-false statement. The single equals is used for assignment. That is used to put a numerical value into a variable name. Others? All right, well, let's see if this works. Yes, please.
When would you use else if instead of else? Like, is else if just for in between, like the function?
So else if allows me to specify a different condition, right? So my if clause begins with a condition here. Is the remainder equal to 0? And then else if gets its own condition, remainder equal to 1. And then else captures everything else. So else doesn't get a condition. And you can have multiple else if statements stacked up after the if statement, okay? So there might be, I mean, I can't think of an example here, right? But you can have essentially as many else if statements, each with its own condition as you want after the if statement. But then the else comes at the end usually. In fact, it has to come at the end, and it catches everything else. So if the input number didn't satisfy any of the conditions associated with the if statement or with any of the else if statements, then the code goes into the else block and executes the commands that are there, in this case, lines 12 and 13.
That makes sense.
Good. All right, I'm going to try to run this. Let's see. Out. Equals and I'll just put in 28 to begin with. And I got a 0, right? So 28's an even number. I got 0, which is false. That seems pretty good. What if I make it 27? I get a 1. That's also pretty good. And let me test my error checking. What if I put in 2.7? I get this error message, your number is neither odd nor even, and I get an NaN in there. All right, so that seemed to work correctly. Now, the next thing I want to do is show you how to allow this function to deal with multiple inputs. So I'm going to save as, MATLAB will behave. Yes, okay. Odd, even, vector. And I'm going to change this so to be back in, and I need to change the name here to be vec as well, because my function name, which is here, has to match exactly the file name that I've specified up there. Now, what I want to do is check every entry of the input vector for oddness. And the most straightforward way to do that, at least I think the most readily accessible way, is to wrap everything that I wrote so far in a for loop. For I equals 1 to length of vec in. So this is telling me to define a sort of counter index variable I, to set it equal to 1, and then every time I cycle through the loop to make the value of that variable I be incremented by 1 unit, okay? And to stop when I get to the length of vec in, or the number of entries that were provided. I need to end that for loop, and then my indentation has gotten off a little bit here. MATLAB has some nice function here, edit and smart indent. So I was able to highlight that and then go to the edit menu, and MATLAB was able to take care of that indentation for me, okay? Now I wrapped it in a for loop, that's good, right? But I'm not done, because notice here, I haven't told MATLAB to only look at a specific entry of that input, and I also have the wrong variable name. So first of all, that needs to become vec in, and then I need to index. I need to pull out the ith entry of that input vector and check whether it's odd or even. So vec in of I, and then else doesn't need that, and then is odd also needs to get indexed. Like that. Okay, so I'd like everyone to look at that carefully for a moment. The things I've done are to wrap my if statements in a for loop, to change the variable name to vec in from num in, and then to index properly, at least I hope properly, so that I check the values of vec in one by one through that for loop for oddness or evenness. All right, so I'll pause for a moment and let everyone look at that carefully, and invite you to unmute yourself and speak up and ask if something isn't clear.
So when you're indexing, the first position of that vector is 1, not 0. Because I think when I did, they usually use 0 as the initial.
Yeah, so many other programming languages use 0 as the first entry of a vector or array, but MATLAB uses 1. So that's why I'm starting my for loop from I equals 1 here. And that will be the first place in the vector. If I try to ask MATLAB for the 0th entry of a vector or array, I will get an error, because MATLAB doesn't recognize 0 as a proper index into a vector or an array. But that is the way it's done in a number of other programming languages.
Thank you.
All right, if you look down at the command line then, right, I'm going to try to run this. And I now need to provide an input vector, 297, 4.3, and 4. So if I've written things correctly, I should get an output vector that indicates even, odd, neither, and even, right? That should be 0, 1, NaN, 0, I think, if I have it right. So let me hit enter, and I did in fact get that, right? Even, odd, neither, 0. And I did get that one error message there. maybe I don't really want that anymore, or I could comment it out. In fact, I guess I'll do that and run again because it's not clear which entry it's referring to. So there we go. That is the sort of vectorization or for loopization of the odd even checking that I had initially written up. So please, everyone, take another moment and ask questions if you have them about what I've done, because next I will release you to work on an example of your own. Okay, then you should go for it. So here is the exercise that I would like you to take a shot at. It's highlighted there. I'll leave my example up on the screen. It should be quite instructive to you. And I'll post it also to Moodle so that you can have a look at it there and download it and look at it at your leisure. So odd, even, and odd. Okay, and so those two M files are up. I probably should add another end there to actually close the function out. That's a good habit, which I hadn't done. So MATLAB didn't give me an error, but that's a pretty good habit to follow in writing function files. All right, I'm going to push the poll out, see how we're doing. Okay, good. Only a very few of you are finished, with about half of you halfway through. So that's fine and appropriate, and we can keep working. for several minutes longer. All right, I'm going to push our poll again, see how we're doing. All right, I see about half complete and a half still working. We're not under a tremendous amount of time pressure today, so I'm going to give another 2 minutes to work on this right now. Okay, let's wrap this exercise now. I'd be happy to take any questions from people if you felt like you got confused or if there's anything you want to ask about. Yes, Valentina. Professor Oki and I do live fairly close to one another and both close to the train tracks. That is very, very observant. He's about a quarter of a mile away from me. He's on the other good side of the train tracks. I live on the downhill, not so good side of the train tracks. But yes, we can both hear the same trains rolling through.
Did you get rid of the for function, Professor, in your script on the left?
Oh yeah, that's the original. This is the one with 4.
Oh, okay.
Yeah. Okay, so if there are no questions, I'm going to move on. And I want to show you something not particularly related to engineering, but that is kind of a good coding exercise. And for some people will be kind of interesting. And this is the idea of what are called strange or chaotic attractors. So there's this word chaos, right? Which colloquially just means things are going crazy. Like there is no order in the world. Things are uncontrollable. No one knows what's happening, right? But in the sort of middle part of the 20th century, chaos took on a rather specific mathematical meaning, and it's applied to systems in which are deterministic. In other words, that theoretically, if I knew the entire state of the system right now, I should be able to predict the state of the system in the future. So one common such system is the natural system of weather, right? We think that if I knew the location of every cloud or every water droplet on planet Earth and their velocities and accelerations, in theory, I should be able to predict the weather perfectly into the future, right? Because it's nothing other than atoms and molecules following the laws of motion. But of course, it doesn't work that way, right? For a couple of reasons. First, because the system is just so large and complex that we can't do it computationally. But also because the system of weather has what we call a strong sensitivity to initial conditions, all right? Which means that if I didn't know the location of a few air molecules in California, right? If I missed them by a millimeter, then my prediction of what the weather might be in Chicago 5 days later would not be just a little bit off, but would be nonsense. So it's an extremely sensitive system. And that, in a sense, makes it feel as if it's impossible to work with those kinds of systems. But in fact, there are ways of working with those systems, and they have to do with these strange attractors. So what these strange attractors represent are patterns that emerge in otherwise chaotic and difficult to predict systems. And the role of these patterns is that although I might not be able to predict exactly the position of a particle at some time in the future, I might be able to predict that its position will lie somewhere on this complicated geometric 3 or multi-dimensional object. So here's an example of one of those right there. And there are some others on this web page. Some of them are quite interesting and even beautiful to look at. And one of the things that I think is particularly appealing about these, just from an aesthetic and mathematical point of view, is that they emerge from pretty simple equations, like the ones that are highlighted on the screen right now. And there are some others as we scroll down. All right, now these were generated using some pretty nice graphical renderings. The one I show you will not be quite as nice, but I want to try to explain what the equation means, and then I'll show you in MATLAB how it gets expressed as well. So let me edit. Okay. So first of all, I want you to concentrate on the right side of the screen, the web page, with the highlighted equations, right? The first thing is that x and y in those equations represent the x and y coordinate positions of a dot on the screen, okay? And what we're going to do to generate the graphics is we're going to plot in a MATLAB window the location of that dot or that particle. The letters A, B, C, and D represent parameters. Those are just constants that go into the system. There are some limits on what values they can take, but those are just numbers that we put into the system that will control kind of how it behaves. So on the right-hand side of the equation, what we have are the current position of this particle, that's X and Y, and then the values of those parameters. On the left-hand side of the two equations, we have these things X new and Y new. So what those represent are the position of that particle 1 unit of time into the future. You can think of it as 1 second into the future if you want. So what we're doing here is we're calculating the position of this particle 1 second into the future based on its current position. So X and Y give us X new and Y new. All right. It's a very simple pair of equations, a couple of, some signs and some algebra. That's all that's in there. And yet patterns such as the one here up above emerge from those very simple equations. This is an example on the left then in MATLAB of how to code that recurrence, that set of recurrence relations. And I'll take you through it a little bit here. So first of all, the particle has to start somewhere, right? And so these lines 9 and 10 define where that particle starts. In this case, I'm starting it at a coordinate location of X equals 1 and Y equals -1. N here is the number of iterations, the number of times I'm going to calculate an updated or new position. A, B, C, D, these are the constants, numerical values that I've chosen. I think I've chosen them to create a pretty nice figure. I'll initiate some graphics here. And then these two lines, 27 and 28, all right? Those are really the guts of the code here. Those are the MATLAB versions of the equations that are on the web page over here. So X new and Y new have been substituted by Xi plus 1 and Yi plus 1. So there I'm using indexing to indicate that these are storing Xi plus 1 and Yi plus 1. Those are storing the position of this particle at the next time instant, one time instant into the future. Xi and Yi, those are the current position of the particle. All right. And then A, B, C, and D are the constants that appear in here. So over on the right-hand side of the equal signs are the present position of the particle, Xi and Yi, and the constants. And on the left side are the new or future position of the particle. This is buried inside of a for loop, right? Because I want to do this repeatedly so that I can track the motion of this particle around its strange attractor or chaotic attractor. And then this is some plotting stuff. Basically, this is set up to plot every 100th time through the loop just to make the graphics a little bit faster. And then if you try to plot things, replot things too quickly in MATLAB sometimes, it doesn't update. So this pause command just tells MATLAB to stop what it's doing and take a very, very short, in this case, a very, very short breath before moving on to the next command. All right, so I want to just run this for you and show you what it looks like. I should have a figure window up here somewhere. Yes, so let me move my figure window down. All right, and what you see are dots appearing in that figure window, right? And each of those dots that's appearing is a new position of the particle that is being modeled by these recurrence relations. And they're still appearing, right? And you can see that now this pattern emerging from those seemingly arbitrary, that seemingly arbitrary pair of recurrence equations, right? I mean, I think this is pretty striking and rather amazing. It's nice mathematically, right? Without going into a ton of details, I will say that this sort of mathematics of chaos theory has real applications in the world of engineering and physical sciences and the world around us. And one of the appealing things is that at some level, right, we can do some work in this area that is relatively accessible without getting into calculus or probability or other complicated branches of mathematics. So this is continuing to fill in. I want to run this one more time So I'm going to Control C here to quit the execution. And I'm just going to let you watch that emerge again for a few moments. Okay. Let me Control C and quit that one. So that's an example of how to implement in MATLAB one of these recurrence relations. And what I'd like you to do, the one I'm giving you is not, it's sort of interesting looking. It's not quite as beautiful, I think, as these Fractal Dreams one, but it's this one, which is called the Gingerbread Man fractal. The equations are here. Again, we have X and Y coordinates. On the right-hand side, X and Y appear. There are no constants in this case. And on the left-hand side, new X and new Y appear. So if we look back at the function that I had written, and this is now available on the Moodle site for you to download, right? I actually give you some instructions on how to modify this into the Gingerbread Man fractal, okay? So I would like you all to download the Fractal Dreams M file from the Moodle site and see if you can modify things in there so that it implements the Gingerbread Man fractal instead of the Fractal Dreams fractal. And a suggestion is that you really only need to deal with updating lines 9 and 10, getting rid of lines 14 to 17, since those constants don't appear, and then, and this is the part that requires some thinking, modifying lines 27 and 28 so that they reflect the Gingerbread Man recurrence equations instead of the Fractal Dreams equations. All right. The link to the web page is on today's PDF. It's this one here that should be clickable in your PDF, so you can go there. But I will also leave up on the screen my own version of the Fractal Dreams code and the web page on which the Gingerbread Man is described. All right. And as usual, as you're working on this, feel free to speak up and ask questions about anything that would help you succeed. All right. Have at it. All right, I'd like to see how everyone's doing here. All right, about 75% halfway through, about 20% complete. So that's a good sign that we should allow a little bit more time. Let's take another 2, 3, 4 minutes. Yeah, so I see one comment from Benjamin that I think the way it's coded, it comes out rotated a little bit or mirrored with respect to the way that it's in the on the web page. We could probably cure that with a well-placed negative sign or two. Kitty Lovell seems impressed with what she's seeing. I like that. I think I'll ask would anyone like to share their screen and show it running for the rest of the class to see? If so, speak up and I will stop sharing my own and give you control. Because that's a pretty bold request to ask for a volunteer in front of 70 of your classmates, but maybe someone will say yes. No takers, not yet at least. Oh, someone just tried to say something. Who was it?
Yeah, if no one else will.
Luke Burns, all right. Thank you, Luke. So you should be able to share now.
You also get to see what happens when you don't put semicolons at the end of your equation.
Yes, I believe Carly Bell also had that experience. That is why we have to remember Control C. Control C saves us.
Gingerbread man.
All right, Luke. So can you run it from the beginning one more time? Let's throw those semicolons in there. So can you Control C in the command window? Good. And let's put those semicolons in. There we go. And it's filling in pretty nicely. It also, as you'll notice, it also runs a lot faster without those numbers all being dumped to the screen. And that's actually a useful thing to have noticed. So there it is, and it's filling in. So you could do crazy things. You could play with colors, right? You could experiment to make this look maybe a little bit more visually compelling. But again, I think it's an interesting illustration of how relatively simple mathematical expressions can lead to relatively more complex geometric phenomena, right? And I mean, there's no way you could look at those equations and try to understand what kind of geometry was being defined. Because another thing, and actually, Luke, would you just run it one more time for us? If everyone watches carefully where the dots are appearing, you know, they're not appearing in any sort of obviously organized fashion. It's not like part of the figure gets filled in and then you move to another part. They're appearing in what appears to be almost a random uniform distribution across the whole gingerbread man. But over the course of time, we're able to see this pattern emerge. So I find these exercises pretty compelling. Luke, thanks for sharing that with us. You can go ahead and stop sharing. Great. You know, I'd encourage you, if you have that Fractal Dreams code, play around with the parameters and see if you can get some other interesting shapes and patterns to emerge. That could be fun. But more to the point, the object of this exercise is really to get you more comfortable working with indexing, right? and the idea of what these i's and i+1s that are inside parentheses actually mean in terms of generating vectors in a for loop, and using what are called here these recurrence relations. So does anyone have anything else they'd like to share or show or ask about? I'm happy to take questions for a minute or two here. Then good luck getting started on lab. This week there will be a few videos uploaded to go with the lab, one for each question that's on the lab assignment. As I said, this week's lab is more challenging. And so I'd encourage you, if you don't already, I'd encourage you to watch carefully and pay attention to the introductory videos. There will be some useful examples in there, and some stuff that is actually, sort of really walking you through how to do some parts of the lab. So please do make use of the videos this week. That lab, though, is not due for 2 weeks because of the intervening midterm. All right, I think that's all I have for today, then. I'm happy to leave this meeting open for another 5 or 10 minutes. If anyone does have a question or something they want to discuss, or even just chat. I got to chat with Joshua Virkeland last Wednesday and learn about a little bit of his life involving Norway and South Africa and his name pronunciation. I kind of enjoyed that. So if any of you want to hang around either to talk about class-related things or not, I'll leave the meeting open and stay on here for another five minutes or so. Okay, to the rest of you, have a good afternoon. Bye-bye.
Have a good one.
Thank you.
Thank you.
You're welcome.
I have some questions about the first activity, because I keep on
Yes.
getting errors.
Sure, today's first exercise.
Yeah.
Okay.
Let me share my screen. I mean, I think I'm obviously I made a mistake somewhere because it's like not
Yeah,
it's
go.
saying that I'm not outputting I guess the output.
Yes. Okay, let me look here. So output is less than or greater than input. If input is less than 50. Okay, so in that line 2,
Sorry.
right?
Yeah.
Tell me what you think that MATLAB code is doing. Or what you intended it to do.
And I
Maybe that's
intended
another
it
way
to
of
like
putting
I guess plug in an input. Oh, but should I put it as a variable like I guess.
No, don't change anything yet, right? Like, I
Yeah.
really want you to try to explain to me what you were hoping to instruct MATLAB to do with that line of code.
I mean, I was trying to let MATLAB plug in the input and then test to see if it is less than 0, and if it is, then the output would be 0.
Okay, less than what?
Less than 50. Less than 50.
Less than 50. Okay, so what is the equals 0 doing there?
That's to check. I guess that's to check if it is double equals to check if that's like to check if the statement is I guess true or false. But
Okay, so I think there are 2 things going on there. First of all, MATLAB, by definition, when you put a condition after an if statement, it checks whether that statement is true or false. And Funny and Gabby and Chris, you guys are free to sign off. It checks whether that statement is true or false, and then either enters that if block or doesn't. So you don't need the equals 0.
the double equals.
Yeah, that isn't doing anything there. Now, okay, good. And similarly for the else if. So now I think you're in business.